All right, 5.1 notes, example 2. Here we're talking about a tape diagram. Tape diagrams are one way we can represent ratios. So we have an art student who is mixing different amounts of paint to create new colors. Each of these boxes represents ounces. So this box here represents 1 ounce, 1 ounce, and so on. We're going to write a statement that describes the relationship between amounts of paint shown in the diagram. So here in the diagram, we have a ratio of red to blue is 4 to 2. So if I want to write a statement, I could say something like what I just said out loud. The ratio of red paint to blue paint is 4 to 2. Over here with the orange and the yellow, we don't always have to do the first picture first. We can reverse that order. So we could say the ratio of yellow to orange is 3 to 2. And we could say something like, for every 3 yellow ounces of paint, there are 2 ounces of orange paint. Are those the only statements we could write? No, but that is one statement we could write to describe that relationship. The cool thing about these tape diagrams is they can be used to make more batches, so to speak. So we can kind of think of this as a recipe for one batch of the orange and yellow paint down here. And if we want 2 batches, we can double everything by putting a 2 in the box. I'm lazy and I would rather not have to draw more boxes every time I want to double something. So rather than drawing all these boxes, we're going to just put the amount we want to increase it by, in this case, doubling it. So 2's in all of the boxes. So now we have a ratio that is 4 to 6, where we used to have 2 to 3. So in one batch, we saw 2 orange and 3 yellow, and we had a total of 5 ounces of paint. Then when we doubled it, we had 2 batches. We get 4 orange, 6 yellow, for a total of 10 ounces of paint. So what do you think is going to happen if we want a triple batch? Well, first, rather than drawing more and more boxes, to make a triple batch, we could put 3's in all the boxes. And now the amount of orange for a triple batch would be 3, 6 orange and 3, 6, 9 for yellow, for a total of 6 plus 9 would be 15 ounces. And hopefully you're seeing a little bit of a relationship here. 5, 10, 15, 3, 6, 9, 2, 4, 6, where each time we make our recipe bigger, the ratio is adding itself. So it's adding 2's here, 2 plus 2 plus 2. It's adding 3's here, and it's adding 5's here. So for some partner practice in class, we looked at how many ounces would a triple batch of red blue have, and how much orange is needed if the total yellow orange is 20 ounces. If you didn't do this in class, I encourage you to pause the video and try this on your own. I'm going to go ahead and begin solving. So a triple batch means we have 3 of the recipe. So instead of having 4 reds, we now have 3, 6, 9, 12 red ounces and 3, 6 blue for a total of 18 ounces of that red blue paint. And if we have how much orange is needed for the total yellow orange is 20. Well, remember back on the previous page where we had this pattern going on. Hopefully, if you know your fives, we know that 20 is going to be the next number here. So we can assume this is going to be a quadruple batch. But if we weren't sure about that, we should at least know that one recipe makes 5 ounces, and we want that to multiply by some amount in each of the boxes to make a total of 20. Well, 5 times 4 would give us 20. So I'm going to put a 4 in each of the boxes. So orange would have 8 ounces, yellow would have 12 ounces, and if I add those together, I do get 20. But the question asked for how much orange, so my answer is 8 ounces of orange. Last one on your own. The following tape diagram represents the ratio of shirts to sweaters worn by a group of people in a room. We've got 3 boxes for shirts, 2 boxes for sweaters, and the directions say write the ratio of shirts to sweaters. And if there are 10 sweaters, how many shirts are there and how many total people? Pause the video and try this on your own. All right, now that you've tried it, let's do this together. We have writing the ratio of shirts to sweaters. We want the shirts number first and then the sweaters. So this ratio would be 3 to 2 with a colon, or we could write it as 3 to 2 like that. Since the last word wasn't total, I wouldn't necessarily write this one as a fraction unless I included the labels with my fraction, like 3 shirts per 2 sweaters, like that. So these are the 2 ratios I would have written. If there's 10 sweaters, how many shirts are there? So if there's 10 sweaters, well, in our original recipe, we have 2 boxes for sweaters, right? 1, 2 for the sweaters. And it's saying that this amount is going to equal 10. So 2 times what's going to go in the box makes 10. Oh, 5. 5 here and 5 here would make 10 total. So if 5 is going in the boxes and it's saying how many shirts are there, then in the 3 boxes for shirts, we're also going to put 5s, and that would be 5, 10, 15. So there are 15 shirts if there's 10 sweaters. And the second part of that question is how many total people? So 15 shirts to 10 sweaters means a total of 25 people. 5, 10, 15, 20, 25. Yes. All right. So here's a summary of the things that we learned today. There are many ways to write and represent ratios. A ratio is a way to compare or describe 2 quantities or numbers in a group. A tape diagram looks like segmented tape and is one visual way to show the relationship between quantities. It's helpful to think of a tape diagram as a recipe that can be doubled. or multiplied by the same amount in order to make bigger batches.